Hi, my name is Maxdoni Miot and my matrix number is BB2211170743. And I'm gonna present part 1, which is construct appropriate graph and chart to compare the relative frequency and cumulative relative frequency between the two metrics. Next, for the relative frequency, I be using histogram. As we can see here, the both of the graph is positively skewed, and for the first one is number of visits. The class interval has 6 class, which is 0 to 10 million, 10 million to 20 million, 20 million to 30 million, 30 million to 40 million, 40 million to 50 million, 50 million to 60 million. So the frequency of each class is, the first class is 0, second class is 0, third class is 4, fourth class is 14, fifth class is 10, and the sixth class is 2. And sum it all and we got the total of 30. So for the relative frequency of number of visit, how I get it? By divided by frequency divided by the total 30, which is the first is 0 divided by 30 equals to 0. Second class is also the same. In the third class, 4 divided by 30, we got 0.13. The fourth class, 14 divided by 30, we got 0.47. The fifth class, 10 divided by 30, we got 0.33. The sixth class is 2 divided by 30, and we got 0.07. Okay, for the number of purchase, it is also the same for the relative frequency. We just divide the frequency divided by the total of 30, but the class interval is different, which is the first class is 0 to 45 million, 45 million is 90 million, 90 million to 135 million, 135 million to 180 million, 180 million to 225 million, 225 million to 270 million. So the frequency of the number of purchase order is also different, which is first class is 0, second class is 0, and the third class is 5, and the fourth class is 15, and the fifth class is 9, and the sixth class is 1, and we got also total of 30. So for the graph for cumulative relative frequency, I am using OGIF. So how get this graph is by using the data cumulative relative frequency, which is for the first class 0 to 10 million, cumulative relative frequency is by looking at the relative frequency, which is 0. And the second class 10 million to 20 million, the relative frequency is still 0, and we got cumulative relative frequency still 0. And the third class 30 to 40 million, the relative frequency plus by the previous cumulative relative frequency, which is 0.13 plus 0, and we got the cumulative relative frequency 0.13. For the class 30 to 40 million, the relative frequency 0.47, we plus with the previous cumulative relative frequency 0.13, and we got cumulative relative frequency for the fourth class, which is 0.6. The fifth class 40 to 50 million, we got the relative frequency 0.33, and we plus with the cumulative relative frequency 0.6, we got 0.93. 50 to 60 million, the relative frequency is 0.07, we plus with cumulative relative frequency 0.93, and we got 1. And for the number of purchase order, the cumulative relative frequency we follow as the previous one, how to calculate.
Hi, my name is Ezekiel Lee. My matrix number is BB221108119. So now I will present part 2, which is calculate and compare measures of center locations between the two metrics. So one of the measures of center location is arithmetic mean, which is often referred to as the mean or average. So to find mean for this table, we can see sample mean formula is the most suitable for this calculations. So for number of visit, we total up the number, which is from 53.8 plus until 35.7, and we will get 1131.4 million and divided it by 30, which is the total e-commerce website, and we will get 37.71 million. As for number of purchase order, also the same, we total up the number, which is from 199.4 plus 231.9. We plus it until the last number, which is 172.8 million, and we divided it again with 30, and we will get 166.82 million. To find median, we have to arrange the data in ascending order, which is like the table provided. So after that, to find median, we have to know the average of two middle value if the number of observation is even. So from here we can see the number of observation is even, and so that we take 15 and 6, the position of 15 and 16 as the two middle value. So we calculate for the number of visit, which is 34.1 plus 34.9, and divided it by 2, we will get 34.5 million. As for number of purchase order, we take 163.3 plus 164.5 and divided it again by 2, and we'll get 163.9 million. To find mood, we have to find the most frequently occurring value in the data set given. So for the mood for number of visit is 34.1 million, since the value is the most frequently occurring or pure value in the data, which is on the positions of 15 and 14. As for the number of purchase order, has no mood because there is no value that is appear frequently in the data given. So that's all from me. Thank you.
Hi, my name is Shafiq bin Devi. My matrix number is BB22110798. I will present part 3, calculate percentiles and construct box plot for each matrix. First of all, we have to arrange the data ascending order to locate the position, which is by using the formula LP equals to number of total position plus 1 multiplied by P divided by 100. So for L25, 30 plus 1 multiplied by 25 divided by 100 equal to 7.75. L50 is 15.5. L75 is equal to 23.25. So based on percentile location for number of visit, L25 will get 31.95, L50 will get 34.5, L75 will get 45.43. For the number of purchase, L25 will get 140, L50 will get 163.9, L75 will get 197.55. For the 5 summary values, minimum for number of visit is 23, maximum is 44.2, quarter 1 is 31.95, quarter 2 is 34.5, quarter 3 is 45.43. For number of purchase, Minimum is 116.5, maximum is 231.9, quarter 1 is 140, quarter 2 is 163.9, quarter 3 is 197.55. For detecting outliers, number of visit, IQR equals to 20.22, and left and right whiskers is 8.95 and 8.77. Therefore, there are no outliers. For number of purchase, IQR is 86.33. For left and right whiskers is 23.5 and 34.35. Therefore, there are also no outliers. Find symmetry. Number of visit, median minus quarter 1 equal to 2.55. Quarter 3 minus median equal to 10.93. The median is left of center. Compare whisker length. It cannot determine skewness from the box plot. For number of purchase order, median minus quarter 1 is 23.9. Quarter 3 minus median is 33.65. The median is left of center. Compare whiskers length. The distribution is positively skewed. Lastly, this is the box plot for each matrix, which contain of minimum value, quarter 1, median, quarter 3, and maximum value. That's it from me. Thank you so much.
Hi, my name is Adam Andrew with metric number BB2211080, and I will present the part 4, which is the measures of dispersion between the two metrics. Firstly, to find the range, you need to find the highest and the lowest value for the traffic and the conversion. After that, we minus the highest value and the lowest value to get the answer. We can see that the range of the number of purchase orders is considerably greater, which is 115.4 million, suggesting a more widespread distribution of values than the range of the number of visits of 31.2 million. Next is mean absolute deviation, or MAD. MAD is an average of the absolute difference between the observations and the mean. To find the MAD, we are using this formula, which is the total of number of visits divided by 30, and then we got 37.71 million. And then we use this amount to minus all of the data for number of visits, and the total is 223.44 million, and we divide it with 30 to get the MAD, which is 7.45 million. For number of purchase orders, we are still using the same formula but with different figure only. And then we got the total of MAD of 25.66 million. We can see that the number of purchase orders demonstrates a higher mean absolute deviation with 25.66 million, indicating a bigger average deviation from the mean in comparison to number of visits of only 7.45 million. Next, the variance and the standard deviation. So, this is the formula for both variance and standard deviation. For standard deviation, we only need to square root the variance. For number of visit of variance, we divide all the total from the data with 30 and then minus with 1 to get 76.1 million. And then we square root the answer to get the standard deviation of 8.72 million. For number of purchase order, we repeat the same step and get the variance of 987.59 million and square root the answer to get the standard deviation of 31.43 million. The number of purchase orders exhibits a higher variance of 987.59 million and standard deviation of 31.43 million, indicating a greater degree of dispersion compared to the number of visits with only 76.1 million and 8.72 million. Next, we need to find the coefficient of variation for both numbers of visits and number of purchase orders. All we need to do is divide the standard deviation with the mean to get the answer. As we can see, the number of visits indicate a greater coefficient of variation of 0.23, indicating a substantially higher level of variability in relation to its mean when compared to the number of purchase orders of 0.19. To summarize, the number of purchase orders consistently shows higher levels of dispersion in terms of range, MAD, variance, and standard deviation. This suggests a wider distribution and greater variability in contrast to the number of visits which has lower level of dispersion, indicate less variability and a more consistent distribution of values.
Hello, my name is Max Tony and I will be presenting the part 5, which is calculate and interpret measure of association between the two metrics. So to find the covariance between the two metrics, we use the formula S xy equals to the sum of x minus x bar multiplied by y minus y bar and divide by n minus 1. And using the Excel, and we got the SXY is equal to 5130.364 divided by 30 minus 1, and we got the answer 176.9091. This shows a positive relationship between the number of visits and the number of purchase order, which means both are in the same direction. So for the correlation coefficient, we use the formula Rxy equals to the covariance. We divide by the standard deviation for x and we multiply by standard deviation for y, and we got Rxy equals to 176.9091 divided by 8.7237 multiplied by 31.426, and we got the answer 0.6453, and a correlation coefficient of 0.6453 indicates a moderate positive linear relationship. This is because the closer the correlation coefficient is to 1 in the positive direction, the stronger the positive linear relationship. However, the strength is considered moderate rather than strong because of the correlation coefficient is not very close to 1. I think that's all from us. Thank you.